I do not know Novapoint.
Okay.
Okay. Let's see here. Yes, Leif just came in here.
Yes. Yeah. Hi.
Hello, Leif.
Hi.
Okay, you decide. I can start from the beginning if you want to. It's no problem.
I think it's okay that you start from the model you have on your screen right now.
Okay. Sure. Okay. My name is Perram, and I come from the Vianova office in Sweden, and I'm the product owner of Novapoint District Heating. It's a relative small module if you compare to the bigger models we have, like water, sewer, or road. But it's very good that it's one of a kind. We don't really have another product on the market that can compete with district heating in a 3D as a 3D tool. So Novapoint, if you compare it to AutoCAD and Civil 3D that you are used to working with, the difference is that we let's see here, my English isn't so good. You store all your data in your project in an external database. You still project in AutoCAD with Novapoint as an application to AutoCAD, but you project against everything you have stored in your database. For example, the terrain model that we have here. So Novapoint base that you see here now, it's where you start your project, you create your project, and here I have some what's it called in Danish? Nivåkurvor.
Højdekurve.
Höjdkurvor.
Yeah.
And that's just from a DVG file that I imported in, and it's in 3D, of course. And I used the Höjdkurve to triangulate, as you see here. And it's the same as in Civil 3D. You use 3D lines or objects to triangulate to get a surface as we have here. So once you store the data, you can model it in here. Here I make a surface. And I also have some buildings here that are polygons I have imported in. And I used a function named extrude to get a volume of the houses here. So that's a little bit short of Novapoint base. It's basically where you start your project and import all the data you need to work with. Once you have terrain model like we have here, we can create a district heating activity, as we call it in Novapoint. And after that, we can move on to the AutoCAD platform to start projecting over there. And now it's in Swedish here. Fjärrvärme is the Swedish word for district heating. So what I'm going to do is I'm going to create an activity for district heating. So I just click here on Fjärrvärme, and I can name the district heating model if I want to. What's important here is I choose what I want to see and count against when I start the project. So choose the beräkningsunderlag, I don't know the English word for it, but I'm going to choose my surface here. That's exactly as in Civil 3D. You choose the surface you want to calculate against. So I just mark that box. And then I also can choose existing objects to see my profiles or my sections. And then I can choose my houses here, for example. If I have some existing pipes, water and sewer pipes, or other types of pipes you want to see when you cross with your district heating, you can also choose that. In this case, I only have houses. And then you see here I have one object, that's the surface, to calculate against, and illustration objects I have 31 houses. And then I just click the green check mark here, and then we see that the activity is created. Once I have done that, I can basically move over to AutoCAD, and down here we have a Start AutoCAD button, and then you see the AutoCAD that you are used to are open here, and you have both of the programs opened parallel now. So if you have two screens, you can have this on one screen and AutoCAD in the other screen. What we see here is the exact same place as this area here, same coordinates, but in a plane view. As we see here, this is the 3D view. So it's important that we draw our district heating lengths here inside this area, because that's where we have a surface. So if we draw something over here, we don't have a terrain to calculate against. So the difference when you have Novapoint with AutoCAD as a module, extra module, is that you get some extra ribbons here. So Novapoint Base is a ribbon where you can draw things from your quadri model, from your terrain model into AutoCAD. You have some simple functions for drawings, templates and stuff. And you can also load which models you want to work with. If you have like here, if you have a road and water and sewer and landscape and so on, you can activate them in here. If you only have base and district heating, that's the one you need to activate in here. Once you have done that, all the modules come up here. So district heating is a separate module, so it's a separate ribbon for that one. So to start the construction here, we need to choose this activity we just made here, Fjärrvärme 1. So I go into the activity button. Sorry, I need to do it from here. And I choose this Fjärrvärme 1. So now the Novapoint knows that I calculate against the definitions I put in here. Do you understand what I just said? How the activity works between AutoCAD and Novapoint?
Yes, thank you.
Yeah, okay. So district heating works like this in Novapoint. You have a configuration that there you can create sections, already defined sections that you use when you start drawing. So if we go in here the first time, we have a standard configuration that's included in the installation of Novapoint, and it looks like this. We have 4 different sections here that we see, and we can create our own sections if we want to. And what we see here is just a preview of how the section works with what pipes we have, what dimensions we have, what Oh, the I don't know what it's called, the ditch or the grave, the geometries for that.
Yes.
So all this we can define in here, and district heating works with the suppliers. And in the Swedish version, we have two suppliers, KVH and Power Pipe.
You don't plan to add Logstar?
No, not at the moment, but you can always put it in yourself, because if you see Power Pipe here, it's from their product catalog, all the right dimensions and lengths and series. But if you want to add Logstar, you can just copy Power Pipe. You have a copy button here. You can also create new, but if you it's pretty similar to Power Pipe, so you can copy it. And you can add Logstar here, and then you can just change the values however you want from their product catalog.
And twin pipes are also implemented.
Yeah, you have double pipes here. Yeah, that's twin, exactly. So you have single pipes and double pipes.
Can I please see what other do you have F type, for example, F type fittings for twin pipes?
Do you mean like T pipes or?
Yes. Why type pipe do you have this fittings when you have to cross from a bonded pipe to over to twin? And do you have such elements?
If you see here at over it, you see different types of elements, but these are like blocks.
Yes.
That are already defined, so they may not look like you want them to look, but you have parallel T-pipes. That's like this. This is a T-pipe, and you also have the one that goes up and goes parallel with the pipes. But I'll show you a couple of examples when I start drawing.
Okay.
Later.
Yep.
But yeah, as I was saying, you can put in Logstar yourself, but we don't have it in the standard configuration as of right now. So the definitions in here, that's what we have, and you always when you have a green cross, you can add extra information if you want to add an extra dimension or series or whatever. So if you want to create a new section here, you have the green cross, new section, a new row, and an empty grave. So we can just call it test. And to add pipes to this grave, we can unactivate the mountain here. We have a button down here, add pipe, so we can add 2 single pipes. And then we have supplier here as a column. Then we can choose between these suppliers we see in here, KVH, Logstar, and Power Pipe. So then we can choose, it jumps a row if you have to mark the test first, and then we can add Power Pipe to these 2 pipes. Single or double, serial 1, 2, 3, and inner and outer dimension. And if you change the inner dimension and switch row, you see the outer dimension updates automatically. And the picture here updates as well. So it's very easy to make a own section. No problem.
Do you have this is the this is a section for not paved area. Do you have a section for paved area where we have to, or a section for friction material where you have to put how do you call it? The stuff to hold your walls?
No, you can't do that. Here you just can define the grave and what pipes you want and the geometry between the pipes and to the grave.
Because the reinforced grave has a little bit different geometry, so it will be but do you plan to add this functionality?
I'm not 100% sure exactly what you mean with the.
Well, if you dig, for example, if you dig a deep ditch, you have to at some point you have to reinforce your walls with timber, and also for example, in the cities, you don't have sometimes you don't have the space to put such a grave with the inclined walls.
Okay.
So you have to put and also if you have friction material, for example sand, you have to put the reinforcement to the walls.
Okay. We don't have any plans to add it at the moment. We have a priority list that we're working on right now for the new functions, and that's actually the first time I heard about anybody want that enhancement. So at the moment, no, but we can always look at it if it's something we could add.
Well, there must be some workaround if nobody of your type clients ever asked for it. So there must be some workaround.
I don't know. Maybe it's a different way how you work in Denmark or how you work in Sweden, because in Sweden it's almost always not very much distance between this surface and the pipes, so it's never very deep graves.
No, of course not. Not on a large, but I mean, if you have, for example, you need to cross something, and then if you have a twin pipe, they don't have a very large elastic radius, so you have to start long away from your object, and you have to work with an elastic radius. And sometimes you can get a very deep grave, like 4 meters, and then you have to reinforce the wall.
Okay. Yeah. I understand what you're saying, but at the moment we don't have that.
Okay. Okay. Mm-hmm.
Yep. Yep. If we move along here, we have the next thing we can put in here, and that's the lengths of the pipes. And for this power pipe, we can choose 6, 12, 16, or 18. So, for example, we can take 12-meter pipes for this type of section. You can take 12 and 16 if you want to, so you can choose between them. But if you only cross one, that's the one they're gonna draw when I draw my my section. And then you can also define where the cut length is going to be in the start of the section, between the nodes, or in the end of the. I don't know the exact word between the nodes. It's a part, delsträcka we call it in Swedish.
Yeah.
And because this is a database, for it to automatically save, you have to switch the row here and go back again to test to save. You see it jumps if you don't, because we don't have a save button in here. And geometry, you see all the 600 in depth here, and so we can change that to 800 maybe and switch row, and we see that it changes here. And the skyddslager, that's we call it in Swedish, the layer over the pipes is 200, and we see the 2-for-1 grave. We can change that as well, maybe 3-for-1, and you see the grave changes also. Yep. This is just an example of an easy section you can make here.
Mm-hmm.
When you're done, you can just exit, and everything saves in the database. So if I go in here again, you see that my test is here. I didn't have to save anything; it just automatically saves. So to start drawing here, we have something called construction, and it's in this mode that we draw our district heating lengths. So down here in the ledningssträcka, as we call it in Swedish, you have two alternatives to draw pipes, either new or choose line. So if I take choose line, I could choose a drawn polyline here and convert it to a Novapoint district heating line. Or I can draw a new manually. So I can show you both alternatives. The first thing that comes up is a list of all the sections I have. So I'm gonna choose the section test I just made. And then I just start drawing. I'll just make something simple here. So you see the start section where I just click the first node is called N1, node 1, and it's a blue circle around it. And then we see we have a little red pipe here, and that's the cut length that I chose to be in the beginning. And after that we have 12-meter pipes all the way to the next node here, and then we have cut length again.
A question: what about if I have a curved pipe?
Yeah, exactly. You can change.
Because you never do you never do district heating like this.
No, I know. Just an example. I just drew something fast.
Okay.
But if you want to have a curved pipe or a bow, you can just right-click on a node. You need to go from a node to do this.
Yeah.
And then you can go here in here and change it to a bow or a bow pipe. So if you take bågrör, you can just say the area or the length. If you say 12 maybe. You see here it's a 12 meter bow pipe.
Very nice, very good.
And for example, if you want a bow here or a bøy, I need to learn some Danish, I feel here. But you can just click bøy and it automatically becomes a bøy.
Okay.
So that's how it works here. And you also have an automatic optimization here. So if you mark your the length here, you see that you get some brytpunkter that you can move. So if we move this to over here, you see that we get a very long cut length here in the beginning. So you can just right click here and you get a menu with different functions. And then you have something called optimize. So you see it recalculate everything, so you get a new cut length and 12-meter pipes. So basically everything you do here is from a right click on the pipes. So if you just look at the menu real quick, you have show in dialog. So exactly there I right clicked, you see it's marked with yellow here. So we see exactly which element that it is. We can go to the plane file, see how it is here with the if it's any angle that's different. Here's 0 angle everywhere because it's straight. And we can go to the profile to see the heights of each node here. And we can go to update, because you see here node 1 and node 2, it's called delsträcka 1 to 2. And if we want to change to another section here between node 1 and 2, we can just mark it and go to the update flick here, and we can change to another section and click update. So the section we choose in the beginning when we draw the first length here, that's just the ground. And then we can change afterwards in between nodes. If we continue to look at right click, we can change elements. For example, we can change the lengths. We can set the cut length in the middle of between nodes. We can erase elements. And some other things, we can put in a node afterwards if we want to in here. We can delete the whole thing or move. So most of the functions are right click on the pipes here. So this is the plane view we see here, and if we want to make a change, we do it here. If we want to see the profile, we have something called construction profile. And what we see here is we see the yellow line here is the surface that we have here, and the red line here is a offset from the surface, just to see that we are have enough what's it called, distance between the pipes up to the surface. And this value you can change if you want it lower or higher. And as you can see, every node it's with 800 or 600 in distance here to the surface. But between the nodes it's just straight. So if you want to move something here, for example, here we got a lot of distance to the ground, we can just right click and put in an extra node here. And then you see it's automatically a node here also. So it's dynamically updated here. And then we can click the node and just take up that one side. And we can do the same over here. Maybe we can put in a node and get this down a bit. And then we have to optimize to get it straight. Let's see here. So yeah, just an example to show you how you have to put in nodes to grab this one up and down. Here you can just go up and down. Even if I'm over here, you can only go up and down. So if you want to change anything, you have to do it in the plane, or you have to put in an extra node here.
And so can I put curved pipes here in the section, log section?
No, but if you have a curved pipe here, and now I just removed it for some reason, but if you have a curved pipe here, it's also curved in the profile, but you can't right click in here and change it to a curved pipe in the profile, but you can do it only in the plane. So that's how it works. If you want to change in profile, you do in the construction profile. If you want to change in plane, you see here it's a different DVG here, so you want to save it to as a drawing. And if you want to make changes in the plane, you do it here. So that's one way to do it. If you want to go from a polyline like this, you can just take this choose line and just click on the polyline, and it converts to a Novapoint district heating directly. And then you can work with, put it in bow pipes or boats. Or the third alternative is that you do it more detailed between each node. So if I choose a start section here, then you see I have different alternatives down here at the command line. We have bow, length, angle, bow, or regret. So we can, for example, take bow here and 90 degrees. You see we directly get the bow. And again, I can put one directly after. with a negative value. And then I want to go straight out from this bow with 0 in angle. Then I can choose avvinkling in Swedish and set the angle to 0. And then you see I go straight out, even if I'm up here with the mouse. You can also put a value of 1 or 2 in the grade. And then if I want it free again, I can just click free and choose the angle I like. I can also take curved pipe here, and you see it's by default it's go to the right and with a special radius, but I can change that radius or angle. Just click bow grade, and you see the active curve grade is 17.19. So if I have a negative value, minus 18 for example, it goes to the left instead. And then I can move to straight pipes after that, and with 0. Yeah. So this is also an alternative you can work with. A lot of our customers, they like to start from a polyline and move and work out from that. If we check at the T-cross pipes, we can just right click on a node and put in a T-cross and 90 degrees. It looks like this. And from the T we can just right click on the node with a new section that goes out from that cross, like this. And if we just right click on the T-cross, we can see how it looks like, and we can change the length of some of the elements here, or the height. Another type of T-cross or a parallel T-cross, it's called, is if we have 0 or 180 degrees in grades for the angle. And then it looks like this instead, like a parallel T. Is this what you meant earlier when you asked about
Well,
F?
yes, F for twin pipes. It's almost the same. Just when you put two bonded pipes into a twin pipe, but it's not exactly the same. But okay, it's no problem.
Okay. Yeah, but this is the two different types of T-pipe elements that we have in the program now. And here you can also, if you have a negative value, you get the stick under instead of over. So this is just the example how you can work. But now we're in the construction dialog. We like outside the AutoCAD drawing right now. Even if we draw in AutoCAD, we haven't drawn it to the DVG file yet. But if I click here, OK Draw, you see that this comes out to AutoCAD with straight lines. Let's see here why it's loading. So this is just an ordinary line, and with a layer and yeah, everything. And you can choose which color and layer it's going to come out with. This is just a default value. So here we got two pipes, and we got a centrum line here. And each node get a circle around it, and we can move this if we want to. We get a carp where we have cut length and sections here every 50 meters. And once we have some changes here in the angle, you see the text here, minus 9.2 degrees there. And when we put in extra nodes, as we did in this length here, you see it's come an extra in parenthesis in between. So we can change the numbers here if we want to by going to this function, numerera om noder. Just choose the first pipe, and then read down here. It's choose the first number 1, and choose the following number after that 1. And then you see it changes to 1, 2, 3, 4, 5, for example. What we see here, it's like dead lines that we just draw from our construction. So if I just move this line over here, this is not projected in Novapoint. If you want to make a change, you have to go back to the construction dialog, and you see the line jumps back. So it's in here we have to move for it to work. So this is more for presentation when you make drawings. If you want to make a profile of this, we have a function for that as well. Draw longitude profile. And here you can choose which one. Now I have 4 different, one here, and one here. And also from the T-cross I have 1 line here. So I choose which one I want to draw. I choose where I want to draw it. And then here we only have Swedish and Norwegian standard here. So we don't have a Danish drawing standard, but I guess it's pretty similar. Now I have the scale is pretty bad here, but as you can see, we get the surface and where the pipes are. Every time we have a node, we see where length scale here. And we get information about the dimension and then height of each. I don't know the skarv. We call it skarv in Sweden. I don't know the English word or English word. But this is almost what you present in Denmark.
Yeah.
Yeah. Okay. And here we have the node, and each time it happens something, we get a text here. Like here it's a 9 degrees angle change, and so on. You can also draw sections if you want to, every 10 meters maybe. I don't know if that's so common to present in drawings. You can export this to a PXY file. We can do that just for fun. I call it that. So it's very simple, but it's for entrepreneurs maybe to put it in their machines to know exactly the X, Y, and Z values.
Yes.
So they can import it. And we can also get a simple report of what we have in our district heating model, and it's an Excel file. So we see how many 12-meter pipes we have, how many cut lengths, and you see it's 2 of each because we have 2 pipes. And here when we have radius and angle, it's the bow, and it's an ordinary angle, it's T-cross or bow. Bend. Sorry. Yeah. If you want to see this in NovapointDCM, because maybe in here we have imported a lot of existing pipes, and we want to see it so it's no problem. We can just open a new empty drawing, and we can draw these lines in 3D. So now we have 3D polylines instead. So every point here has a zeta value, so it's in the right right in the height here in the coordination system. I'm just gonna delete the centrum lines because I don't want them. And we can just save this as a drawing tree on the desktop. And then I move along in here and import the lines. I can call it. And I just choose this drawing tree. I chose that it's in the same coordination system. And then I have to convert this AutoCAD lines to Novapoint lines. So I just choose a conversion rule. And then I get them in here. And this is just lines now, but they are in the right zeta. And then we have a function in here to get the lines a dimension called sweep. And we choose what lines do we want to sweep in here. So we just choose this import. You see they are marked red when I box in the here, and then I can choose, is it circular or rectangular, is it top centrum or inside centrum or whatever. You can create a hole in it, and I think it's 16 and 1 point, something like that. And then I change the object to district heating and end. And then it looks like this instead. So you get like a free 3D model of everything you have. So if you see crossing pipes here, or you have a road maybe in here, you can see so everything is correct, and you get a better understanding of what you have done. And if this is not dynamically updated if you do a change here, so if you do something in the construction maybe, you have to make another one of these 3D drawings and import it again in here, and just choose this import to so it switches to the new one instead, and then it upgrades here. But yeah, district heating projectors here in Sweden, they are not as far in 3D modeling as other like water and sewer projectors, for example. They work a lot more in 3D.
Yes.
Yep. This is the short version of what you can or cannot do. Yeah. What do you think, and do you have any questions about how it works?
What about the performance of large models? Because we have, for example, 15 kilometers long tracé. And how, if I import this large terrain, it is several square kilometers, how will it be? What is the performance of this program?
Novapoint can take in a large amount of objects, so you can have a very large terrain model in here without it going slow or anything. Because this is a external database, it's not AutoCAD related, so the graphic here is very fast, and you can put in large amount of data in here. So
right.
that's not an issue at all. One issue can be if you have a lot of district heating ledningssträckor, as we call it. This is one ledningssträcka. If you have like 15 or 20 of those, it can be a bit slow when you go in the construction maybe. But what you can do is you can create one activity, as I did here, for each long sträcka. So you can create another one for maybe you have one here and one over here. So you can create an activity for each one, and then it's not going to be that's hard to work with.
Yes, all right. What about localization? It is. I can say that it's Swedish. You don't have other languages possibility.
I believe it's in English as well.
English. Okay.
I have to double check that, but I think so. But not in Danish, as I know.
No,
Yes,
not.
that's okay. English is pretty well. It's all right. English, yes. What about? So, as I understand that to create drawings, I still need to use the standard procedures of Civil 3D. I mean, I need to create a drawing set in Civil 3D. You're not related to drawing creation. You're just related to creation of geometry.
Yeah, you don't need Civil 3D, but you need AutoCAD, a full
Yes.
version of AutoCAD to create drawings.
Yeah.
So that hasn't changed, but you don't need AutoCAD to model your existing data and create your project, but you still need AutoCAD to work with the Novapoint construction and draw your district heating model here, and you still need it to create drawings.
Yes.
That's correct. So to use Novapoint district heating, you need one license of Novapoint base. That's this one, and you need one license of district heating. That's a separate module here for each person. That is.
All right. But the one thing that still bothers me is the longitudinal section. It is the lack of possibility to model curved pipes in longitudinal section. So if you look at your longitudinal section, you can see that you're showing your pipes as breaks.
Yeah.
So, but how are your other customers responding to this?
About curved pipes in profile, I haven't heard anything about that they want to have that. But bends in profile, I have a couple of customers that want us to have that possibility.
All right.
Yeah.
Yes.
But as I was saying in the beginning, this is a very small module in the Novapoint family. It's a small portion of people in this business work with district heating projects in 3D. So it's very small, and it's usually maybe one or two at each consult firm that work with this. So we unfortunately we don't have a lot of sources to develop at a high rate with new functions and stuff like that. If you compare it to the other modules we have that are very big. So that's the reality we live in at the moment.
Do you have a possibility to send me an example of project documentation created with this model? I mean, I just want to see what people are making with this program.
Yeah, I can see if I can get something from some of our customers. I'm not sure they want to share that data.
Yes. If you can.
I can ask. I have a good connection with some of them that I can ask. So yeah.
Just and if you can ask to get a project which covers all functions. I mean, so I can see example of plane and sections and profiles, if it is possible, of course. Okay.
Okay. Yeah.
And maybe list of